Welcome to GlugNet. Glad you can be here, whether you're here in live or via the recording. Tonight we're going to have a presentation on Introduction to AI for Developers by Sam Nasr. Sam is a long-term member, supporter, helper with GlugNet and a sponsor actually through his NIS company. So we very, very much appreciate his involvement in the group, both as a supporter and a contributor. So we're very fortunate to have Sam's talk tonight. A little bit more about GlugNet. GlugNet is the Greater Lansing User Group for .NET. GlugNet has been in existence for 21 years. I have been on the board and assisting running it for 20 of those 21 years. So I'm getting old. Sorry, folks. Anyway, or .NET's getting old, actually. Maybe I should say that. We're based in Okemos, Michigan, and we do meet the third Thursday of every month. That has been our pattern from the very beginning. I think there was like once or twice we deviated from that for very special exceptions, but it's very rare. Like most meetup groups, we're free and open to the public. We're currently virtual only. The hope is that at some point this year we will go to a hybrid model where we will have virtual presenters or in person if we're lucky enough, but then just meet, watch the presentation, and then get some of that social interaction afterwards at a local restaurant or watering hole, and get some networking time after the meeting. So we're looking forward to trying to get that going again. And this presentation will be posted to the YouTube channel, Sam's own YouTube channel, where all the GlugNet presentations are posted. So you're welcome to go there and watch this presentation probably in a week or two. Also, there's all the past ones. So if you want to catch up on all the great GlugNet candy that's out there, you're welcome to enjoy some. And I think, Sam, you also post other groups, right? Not just GlugNet and not just Cleveland.
Actually, the two in Cleveland, the Azure Cleveland User Group, the Cleveland C# User Group, and of course GlugNet.
Yeah, so a lot of
So
really
just
great
those three.
content. A lot of really
Yeah.
great content beyond just what we can offer. Some housekeeping items. If during the presentation, and Sam, do you want people to ask questions as they have them, or do you want to hold them to the end?
Either or, feel free to jump in at any point in time,
Okay.
and then I will also stop at the end and ask for questions.
Okay, sounds good. So while for the convenience and enjoyment of others, while Sam is doing his presentation, please keep yourself muted until you have a question. We would appreciate that very much. And Steve, are there any other housekeeping items I should be mentioning? Okay, I'll take that as a no. All right. At the end of this presentation, there will be, we'll make available a survey, and that survey will ask about the meeting and also give an opportunity to give feedback to Sam on his presentation. Being a speaker myself and knowing Sam very well, I know that he's very interested in getting that feedback. Sam works very hard to put together high quality presentations, and getting that feedback makes them even better. So it'll be very much appreciated. So that'll be available for 24 hours after the meeting. We'll put the code back up at the end of the meeting so you can get a link to that. And I think we'll paste the link into the chat as well. So finally, I want to thank our sponsors. The sponsors are the .NET Foundation. The .NET Foundation is kind enough to cover our meetup.com subscription fees. That helps us greatly. And then, of course, NIS Technologies, Sam's group, sponsors the YouTube channel, the meeting software, GoTo, and really, anywhere he pitches in anywhere he can. So we appreciate it very much. And with that, that's actually when we meet at Dew Point, which we're not doing today. So now it's time for the feature presentation you've all been waiting for. And I know Sam, I know it'll be great. So I'll switch it over to Sam and we'll go from there.
Thank you, Joe.
You're
Highly
welcome.
appreciate that beautiful introduction. Thank you.
Totally unscripted.
It is from the heart.
There you go.
All right. Well, thanks again, Joe. Appreciate the introduction. Hello, everyone. My name is Sam Nasr, as Joe said. A little bit about me. You can find me on Twitter at Sam Nasr. I've been a software developer since 1995. I am a senior software engineer as well as a trainer for NIS Technologies. And I've been certified with a few certifications from Microsoft and still continue to add to that list. In addition, I run the Cleveland C Sharp user group as well as the Azure Cleveland user group. And I've also authored multiple articles for Visual Studio Magazine, did several courses for LinkedIn Learning, and I'm a 7-time Microsoft MVP in the AI field. A little shameless plug, if I may, for the Cleveland C Sharp user group. Much like Glugnet, we meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. We meet, like I said, typically every fourth week of the month. And you can find the meeting information posted at meetup.com at the link listed at the bottom of the slide. So, with all the introductions and shameless plugs aside, let's dive into tonight's presentation, which is an introduction to AI. So, many of you have seen these terms, AI, ML, DL, NN, and it kind of seems like alphabet soup. Pardon me. And you really don't know how to refer to it. And so AI has become the general umbrella whenever we're referring to any of these. But as developers, we certainly want to gain insight onto what is a neural network and what is deep learning and how does it differ from ML and AI. And so basically, as you see here in the diagram, it shows that the neural network is the underlying foundation. It is the smallest building block that we then build upon. And we'll get into what a neural network is in just a second. But essentially, we use that for building up layers. So we get into deep learning when we have multiple neural networks. And then on top of that, then we're able to utilize machine learning. And then we get into AI, which is essentially mimicking human understanding and responses. So essentially, what a neural network is basically you have an input coming in, you make a decision one way or the other, and then you have an output. But you could have multiple layers in between, and so each one is considered a node. As you see in the diagram here, every green item is considered a node, and essentially you can line them up so you have multiple nodes, multiple if-then statements, if you will, that are intertwined with each other. And in the end, you get one single output at the very end. Now, what does that look like in practical terms? Well, let's back up a little bit and let me give you a more practical example. So, supposing, for example, that I was a big-time surfer. I've never surfed, but let's just assume that I am. Now, if I'm going to go out surfing, I need to evaluate a couple things. Number one, are the waves good? Number two, is the line empty or is the beach fully crowded? Number three, is it safe, meaning that there are no shark attacks? And we'll just stick with those three just for the time being. So what I have here is essentially three nodes that I'm going to be evaluating in order to make my decision whether I'm going to go surfing or not. So the input is, do I go surfing as the question? And the output will either be yes or no. In between are these three questions that I need to ask myself. Now, with each question, I'm going to give it a specific weight. So, for example, for node number one, I'm going to give it a weight of 5 because large swells in my area don't happen too often on the edge of Lake Erie. And so if the swells are high, then yeah, I'm going to go for it. I'm going to give that a weight of 5. That's going to emphasize my wanting to go surfing. If the line is empty, yeah, that's good. But being an avid surfer, I'm willing to go surfing if the swells are good and if the lines are full. So I'll give that a weight of 2. It's not that important. But then you look at something like a shark attack. If there's been a recent shark attack, and it's not safe, then that's going to be a weight of 4. And if you notice, because I'm a diehard surfer, then a large swell will whelm a shark attack. So that has a weight of 4 versus a weight of 5 for the swells. The whole point is I'm assigning weights to each decision. Is it really worthwhile for me to go surfing if the waves are good, if the lines are empty, and if it's safe? So each specific item has a specific weight. So I give each node an answer or a binary answer of either yes or no, 1 or 0. And then in the end, I put all those weights together and I have a threshold, meaning, so in this case, it's rather arbitrary, but I'm saying if it's above a 3, I'm going surfing. If it's below a 3, I'm going to change plans. And so in the end, I have my equation where I take my yes and no's, I assign weights to them, and then I have the final threshold of 3, and then I see where I'm at with that threshold. So we see here that there are large swells, so that's a heavy weight of 5. That the lines are not empty; they're full, so that's a weight of 0. I'm sorry, it's an answer of 0, but times 2, it's still 0. It doesn't matter. And then, is it safe? So it's a 1, meaning yes, and that's a weight of a 4. So my two big priorities are it's safe and there are large swells, so it definitely supersedes the threshold of 3. So I'm going to grab my board and hit the waves. Taking all that into consideration, this is an actual example of what a neural network is. So looking at the previous diagram, what we have here, we have all the nodes, they're assigned certain weights, and I feed it an input, a question, should I go surfing? And then it goes through all the individual weights and it answers yes or no, assigns the weights to them. Do I meet the threshold? Yes. And then I get a final answer in the output layer. So this is a very simplistic example of a neural network. Now, obviously, even in real life, there are more questions that I would ask myself. Is the water temperature good, or am I going to freeze? Is there much daylight left so that I can see other surfers without hitting them? Are there a lot of surfing vets out there, or is it amateur night where people are bumping into each other? So I can add in multiple additional questions. And of course, that's going to expand my network to be much more. So being a simplistic example, we went from 3 questions to 6 questions here. But in reality, when we're building a model, we're talking billions and billions of nodes, hundreds of billions of nodes to be specific, when it comes to a large language model. And that's because it can then mimic human understanding, mimic the human response, and not to mention in the reasoning that happens in between as well. In addition, large language models can be very creative. They can design things and draw things for me. So the building block is a neural network where then we build on that. So anytime I have more than 3 neural networks, that is essentially considered deep learning, where now I have multiple networks, and so there is deep learning that's involved. And with that deep learning, then I can develop things out of it, meaning I can build on that and develop machine learning. And machine learning essentially is basically comes in 2 flavors, supervised and unsupervised. So supervised is where I give it data and then I tell it this is good or this is bad. And as we'll see in the example that we'll run through in a second, I'm going to have it do sentiment analysis for a local pizzeria. And I will give it examples of good comments as well as examples of bad comments. And it's going to learn, and it's supervised in the sense that I told it it's good or it's bad. Unsupervised learning is where essentially the model is trained so that it can classify things together. For example, it knows that this is a cup. It would also know that this is a cup, and then it would classify these two together. But then if I introduce something else, then obviously something like this, a cell phone, that wouldn't be classified as a cup. And so it would classify those as 2 separate items, and it doesn't need to be supervised in that, meaning once it's trained, it can then classify items on its own after that. So now this is the machine learning level. To build on top of that and to get to AI, where now I am mimicking human understanding. So I can ask it questions like, um, draw a cup for me, and it would actually draw a traditional cup for me. And then I would say, make it with a large opening or make it with a large handle. And it will then take that and through natural language, and it would be able to respond. Now, when I say natural language, I mean natural language as I'm speaking to you right now. As developers, we are trained on very rigid syntax, right? In C sharp, it has to start with an opening brace. Every statement must end with a semicolon. Strings must be enclosed in double quotes. So it is very rigid, very strict. I can't go outside of that. I can't just say, well, I'm just going to leave a semicolon out. We've all been there and we've seen the kind of errors it generates. But with natural language, it's basically like I'm talking to another human, where if I was to ask Joe, Joe, can you get me a cup? And he would naturally go down to the cafeteria, grab a cup, and bring it back, right? So it is very natural. I don't have to specify the sentence or the question in a specific format. I can just talk to him. So let me pause here for a second. I know I threw out a lot at you, but do we have an idea of what the NN or neural networks, deep learning, machine learning, and AI and how they differ from each other at this stage? And I feel free to either jump in verbally or ask questions in the chat.
Yeah, I have a question, Sam. So you mentioned that the neural network and the
I'm sorry, Joe,
basis.
I can barely hear you.
All right, put my microphone back.
There you go.
Um, so you mentioned that the neural network, deep learning is, typically three or more neural networks. When would you combine neural networks? What would make you think that you should have multiple neural networks?
So it's not necessarily me being a developer and someone who's a practitioner of AI. I come in at more of the machine learning and AI level. It's more of
Okay.
the scientists that develop the neural network, and they're the ones. And like I said, the simplistic example that I gave is very simple.
Hmm.
Realistically, a language model would have billions upon billions, literally hundreds of billions of neural networks
Okay.
or nodes rather. And
Nodes.
so it's very extensive. And it goes in much deeper as far as natural language understanding, where it breaks up words into what are called tokens. And so that layer tends to grow quite a bit in order for it to be able to understand human language.
Okay.
Does that answer your question?
Yes, sir. It does.
Very good. Any other questions? All right, very good. As we proceed, again, please feel free to jump in verbally or through the chat window. And if I miss the chat window, kindly remind me. And so, with that, let's continue on. And so, we are now at a level where we can utilize machine learning. And so, let's take a look at the terminology. So, with regards to machine learning, a feature is what's considered the input value. So, for example, when I'm buying a used car, what are some of the features or the input values that will determine the price? There's the model year, the mileage, um, the condition of the vehicle. All these things contribute to the price of the vehicle. So, features are the input values, such as like I said, the model year, the mileage, condition, etc. And then the output is what's known as my label. That is the ground truth value, and this is what's used to train the machine learning model. In the case of supervised learning, that is. So we have all those features that will essentially dictate what the output price will be. So in a nutshell, features are inputs, labels are outputs. What happens in between is what's called a transform. So this is a type of prediction where I am taking a value in, transforming it, doing some kind of processing on it, and then producing an output value. So that could be done in a variety of different ways depending on the machine learning scenario that I'm utilizing. For example, some of the machine learning scenarios are classification and categorization, where I give it several items and I'd say classify, these into two separate categories. What's a cup and what's a cell phone? There's also regression. So car prices is an example of regression, where as the car ages over time, the price decreases. Um, Something opposite is with home prices. As time goes on, the price increases, but of course, it's also dependent on the input features of the home, i.e., the number of bedrooms, the zip code, school district. All those things affect the price of the home. One of the other features that I'm fond of is anomaly detection, where essentially it will track the usage for a user. And this could be credit card usage, or it could be how often they clock in or swipe their badge to enter a secured area. It will detect any anomalies that are outside of the norm for that user. Another one is recommendations. I'm sure you've all heard of a website called Amazon.com. This is typically where half of my paycheck goes every month. And the reason being, every time you go to make a purchase, it also makes a recommendation. Oh, I see that you're buying a laptop. Well, how about, a nice mouse to go along with it? Or how about a mouse pad to go along with it? Right? So it's making recommendations on previous purchases to the current user and his current purchase. There is time series or sequential data where essentially it's forecasting product sales or spending over a period of time. And so that's used to analyze how much should I increase the price of my product based on previous price increases or previous usage. And then image classification, like we talked about, where it can actually identify pathologies in a medical image. For example, if I have an x-ray and there's a spot of a lung that doesn't look 100% normal, a model can be trained to actually classify that as abnormal that needs further diagnosis. So essentially, these are the various machine learning scenarios that are available to me. Now, if I want to utilize machine learning, it's basically a cyclical process. And let's go with examples like that are more numeric based, like linear regression, where essentially what I need to do, we start at 12 o'clock where we're going to collect and load the data. And then from there, we're going to create a pipeline using the append method. And then we're going to train the model. After the model is trained, we are then going to evaluate the model. And depending on the evaluation, meaning that we're going to test it, depending on the results of that, either we collect more data and train it again, so it would be a cyclical process, or we can just simply proceed to save the model and be able to utilize it in another project, as we see at the bottom of the slide. Okay, so essentially it's a cyclical process: collect and load the data, train the model, evaluate, and then identify whether you need to save the model and use it, or you need to retrain it on additional data. Once you get to the point where you're ready to use the model, essentially in ML.NET, what this is going to utilize is the load method. And then from there, we'll make a call to the create prediction engine and make a call to the predict method specifically and pass it in a value where it can then make a prediction. Everyone with me so far on these concepts?
Yeah, I have a question.
Yes, please go ahead, Kevin.
In the previous slide, why wouldn't you save after the evaluation? Like, wouldn't you want to evaluate your model and say, this is good, this is bad, and then save?
Are you saying so whether I would save it right here or not in between the evaluate and collect load data?
Yes, right. Like at the 9 o'clock where you're evaluating, you get your result.
Correct. That would be a more accurate placement of it. You're absolutely right. This is just essentially to get the point across that it's a cyclical process, but once you're done with it and you're satisfied with the evaluation process, then you would save it.
Okay, yep, understood. Thanks.
I will fix that slide though. Good point. Okay. Any other questions? All right, very good. And so now that we have our model, now that we know what's conceptually happening, how does the rubber meet the road? How do we actually implement this in Visual Studio? So some prerequisites are needed if you're going to be utilizing ML.NET. So first off, within the .NET desktop development environment, as we see here, you need to identify that you're going to load the ML.NET model builder. So this would need to be loaded as part of your environment. Once that's loaded or installed in your environment, then you essentially have three options. And sorry, the slide is a little bit messed up. But essentially, there are three ways to go about adding an ML.NET project into your solution. Number one, you can do it with a UI, as we will do in just a second. Number two, you can use it programmatically, because essentially that's what the UI is doing on the back end, is that it's generating code. And so I can skip the UI and just write the code myself. And I can also do it through the CLI, or the command line interface. All three options are available to me, but obviously I'm going to choose whichever is easier. Now, if you'll notice, what I have highlighted in the slide is that I have a project where I right-clicked on it, I selected Add, and because I went through the builder, I now have that machine learning class available to me in the context menu when I right-click on a project. And so now that I have everything set up, let's jump into a demo. And let me get the right version of Visual Studio. All right, so what I did to prep for the demo, I created a very basic and very vanilla console application. As a matter of fact, all I did was select the console application. I gave it a name of ML Demo TA, and you'll notice here that all it is just the program.cs, and the program.cs is kept very simple. So because I have all the prerequisites done, I'm going to right-click on the project, select Add, and now I have machine learning model as one of the options to add in. I'm going to accept the default name of mlmodel1.mbconfig, and there it's highlighting the object for me. I'm going to go ahead and click Add. And it'll take just a minute. And now it's presenting me with a user interface, all within Visual Studio, and it's going to walk me through what type of model I need to build. So it's asking to select a scenario, and here are the various scenarios that I can select on. Data classification, where it can classify tabular data. Value prediction, for predicting value, for example, sales or trends over time. Recommendations, whoops, I clicked on that one by accident. So let me go back. And if you'll notice, for each scenario, it shows you where these items could be run, either locally, or in some cases, locally or in Azure, depending on how much horsepower you need for running these applications. And we have natural language processing at the bottom, where there are a variety of different natural language processing scenarios that it can perform. We're going to select text classification, and we can run that locally. So we'll go ahead and click that. It's giving me a brief overview of my development environment, and then we'll proceed on to the next step. Now it's asking me for data. So I know the data is housed in this file, and let me go ahead and open up that file separately so we can view it. And all it is basically a flat text file. It's tab delimited, and it contains two columns. There's the raw text, or the comment left in by folks that visited a local pizza restaurant. And then I'm identifying whether that comment is positive or negative. So 1 for positive, 0 for negative. And there is approximately 1,000 lines in here of various comments. Okay. So I'm going to select that file. Now it's asking me which column is which one is the label, which one is the feature. So the column to predict, the label, which is the output, is going to be column 1. The text column is going to be column 0. And now it's showing me a preview of the first 10 rows of the total 1,000 rows that I have in that file. Next step is essentially to start training. And I'm going to go ahead and click this. This is expected to take about 3 minutes. And so because of that, I have a demo that I created previously. And we'll jump into that. Now, after the train step, now obviously here you see in this project, training is completed. It took 190 seconds. And then the best macro accuracy is 67%. Now it's time to evaluate it. So there are some comments that I can put in here. So I can say, I can type in a comment like, did not like at all. And it chugs, and it tells me that it's 99% sure that this is a negative comment or a 0 value. I can also try another prediction and say ample portions and good prices. And then it responds back 92% confidence that this is a positive score. And so if I'm satisfied with that, I can move on to the next step. If not, I can go back and collect more data and retrain it and give it more time for training so that it can go through different algorithms and be able to identify what's the best fit. But let's assume that I'm satisfied with the results here. Now I'll move on to the next step, which is consume. And you'll see that it's giving me some code snippets if I want to be able to execute this and utilize the model that was trained. And I can do this in a couple of ways. I can add this as a console application to my project, or I can add it as a web project to my solution. So either or will work. Now, if I go back to the demo, okay, so this one is still training. So what I'll do is I'm going to add this as a console application. And you'll notice it says add console app again because I already added it as console app 1. But I'm going to go ahead and add it again right here. I'm going to add it again as a console application, and it's saying, do you want to accept this default name for the project? ML model 1 underscore console app 2. Pardon me. I'll go ahead and add that to the solution. And it created another project in my solution. It's another console application, and it's kept very simple. It's utilizing the ML model that I just built in the first project for an ML demo 1. And it's utilizing that where it's instantiating it, and it's passing in a sample input, and then it's going to display the results in the bottom here. So I'll go ahead and run console app 2. Let's make this my startup project. And we'll go ahead and run it. And there's my console window. And if I put that side by side with the program.cs, so what this did was it ran a single prediction of crust is not good, and then it called the model, and it asks for a prediction on all the labels, and all the labels that are being passed in are this sample data. And then we get an output. So the output is returned in this variable called sorted scores with label. And then we simply just parse through and display those. And so if we go to our output window, the sample that was passed in is crust is not good. The output value for that prediction is that it's negative. And then here it shows us a score of 99.48%, 0.49, excuse me, percent accuracy that this is a negative comment. So I was able to utilize Visual Studio with the tools that I know to be able to create a model. And then using all the features within the model builder, I am now able to create a separate application just by simply clicking a button. It added that project in there, and now I can pass it in sample data, and I can respond back with a confidence score as well as an output value. So I'm sure right now you're all standing and applauding about how marvelous this is and how easy to access. But I wanted to pause for a second and see if you have any questions or comments. Thank you for the applause, Kevin. I think it's a very cool feature, all within Visual Studio, all tools and language that I know, and it expedited the ability to be able to train a model and use it all in one-stop shopping. All right, very good. Thank you, Mehul. Okay, so if there's no questions, then we'll continue on. And we can close the window, stop that project. All right, so now we've seen what machine learning can do. Now let's take it up a notch and move on to AI and more natural language understanding. What other features are available? If you go over into Azure, and let me share my screen with you. Before we do that, actually, let's talk about improving performance. So as we saw that it had a score of 67% overall when I trained it on the 1,000 records. Now, if I want to improve performance, what are things that I can do? First, I can obviously provide more data, but not just additional data. It has to be clean, meaningful data, meaning it can't just be gobbledygook. I have to go through, make sure that there are no misspellings, make sure that the data is labeled correctly because this is supervised learning. So I have to give it data and be able to train it on that. Data with context. So obviously this was a simple example, but if you look at things like home sales, obviously some of the things that affect the price of a home, the zip code, number of bedrooms, and then of course the various amenities, whether you have a swimming pool, a fenced-in backyard, number of bathrooms, whether it's been recently remodeled. Also, you have other factors that can drive down the price. Was there fire damage, molds, insect damage, variety of other things? Is it in a flood zone? All these things could also impact the price negatively. So I can't just look at zip code alone and the price of the home. I have to give it context. What else is involved with that home? What else happened to that home that may affect that price? So that's what's meant by data with context. Another way to improve performance is by something called cross-validation. And what this is, it's basically a model evaluation technique. So as I built the model, it basically, if I use cross-validation, it can split that data into several partitions, and then it trains different algorithms on that data set or on those various data sets, and then it compares the results. So this could be a very effective tool for training models with smaller data sets. And then, of course, another way to find out if or how to improve performance on accuracy is by trying different algorithms. By running through the data through different algorithms, it can then select the best model or create the best model for that data. So building on AI, now that we have machine learning, we can build on it and go to the next level with AI or artificial intelligence. And there are a variety of services available through Azure. And these services, essentially, they provide human interpretation, where I no longer have to speak in a rigid manner where the sentence has to be structured in such a way, but rather I can speak fluently and naturally as I would to another English speaker. It's used for building intelligent applications. So not only is it recognizing natural spoken language, but it can also see and understand and reason. Variety of different things that mimic human intelligence and reasoning. So, as you see, I am a C# developer, and I use the capabilities that I have, that I've, as far as running it in Visual Studio. I didn't have to get a PhD in data science or artificial intelligence to be able to utilize these features. The deep core has been kind of abstracted away for me, meaning the building of the neural networks and the deep learning has been abstracted, where now I am using, or I'm a practitioner of the higher functioning features of machine level and AI. And the models are built using the external portals. So for example, if I go into natural language, there are other portals that are outside of it that allow me to access Azure. And we'll see later in another example where I'm utilizing a large language model. I would go into the Azure Foundry that is outside the Azure portal, but they work together. But it's still, I have to go to that Azure Foundry to be able to utilize that large language model. And so once everything is said and done, and I have my model created, as we had seen, I can deploy it in a variety of different ways. It could be accessed as an API, or as we saw, utilizing the SDK within Visual Studio, I can then use it within my console application. So looking at Azure AI services, essentially it provides a variety of different human senses, if you will, artificially. So I have vision, decision, language, speech, and OpenAI, which incorporates a lot of these features within Azure AI services. Well, more specifically, let's focus on speech services, where it offers a variety of things such as speech to text, text to speech, translation, and then speaker recognition. So I will be able to demonstrate the first three. However, the fourth one requires some additional permissions from Microsoft because now it involves some personally identifiable data, meaning I'll be able to identify Sam from a crowd just by hearing his voice. And so with that type of information, it's kept under more secure, I should say. They need to know what you're going to use it for before they grant you access to that. And so with that, let's look at a demo of speech services. And because this is available in Azure, what I need to do is, first and foremost, I would need to create a speech service. So to do that, I would just simply go to one of my resource groups. I typed in speech services, and there is the Azure service that I would need to create. Once I create this, and I won't do it here because it's already been pre-created, but once I do this here, I will then have two identifiable items that I need, my key as well as the region that I'll be running it in. So those are critical because I'm going to use that in my code. And if we look over into my Visual Studio, I now have another project called Speech Services, and then I have the four different speech services available, all done through console applications. So let's look at speech to text. And with speech to text, I kept it fairly simple. There is my subscription key, and then here is my region. And these two are kept in my config file. These are things I don't want to share publicly. They are tied to my subscription. And likewise, when you deploy this, you also want to keep those under lock and key as well. You don't want to give away the keys to the kingdom. But essentially, this is a console application where I am bringing in a couple NuGet packages for utilizing the speech services. And then within my main method, I'm getting my subscription and my region. I'm instantiating my speech config class, and I'm specifying the 2 items for the subscription and the region. And then I'm specifying that I'm going to be utilizing the default microphone. And then it's going to go into an infinite loop where we'll ask, how can I help you? I'll then give it the text, or rather, I will give it the speech through the microphone, and then it will respond back with the text of that spoken words. And then it'll say, press enter to continue, where the cycle will repeat again. Okay, so let's go ahead and run this. Oh, sorry, wrong one. So we want speech to texts, and so we want to select this project. I would like a large pizza with sausage. And there you see it transcribes the words that I had spoken into it. I would like to order 2 large pizzas. As you can tell, I'm a pizza fan. But a more practical example of this is someone who's visually impaired. You can set up a portal where they would press a button, and then they can just speak into the microphone, and then it would take that text, transcribe it, and then we can do further processing on it later, i.e. look for certain keywords, look for a part number that they stated in there, a variety of different things. Or you can piggyback it with other applications where, like a large language model, where you could actually have the user talk directly with the model. So the opposite of speech to text is text to speech. And that's done in a similar fashion. Again, getting my subscription and my region. And then here it's different because I have a variety of voices that I can choose from. And as you can see, I experimented with a couple, commented them out, but then eventually I settled on Irish Connor, where he's going to be responding. So in this case, I will be entering in the text, and then it will pass it to the speech synthesizer class, and then respond back with the text that's returned from it. And so once we go ahead and run that, so enter text.
I would like to order part number 1123.
Did that audio come through?
Yes, it did.
Yes.
Excellent. All right, very good. And so as you might have picked up, there was a little bit of an Irish accent, thanks to Connor and the selection that I chose here. Okay. Fairly straightforward. Any questions on that? Okay. Moving on to the third one, which is my favorite, speech translation. Can you guess what we're going to be doing first? All right, just like we did in the other 2 demos, subscription and the region. And then here, we're going to be targeting 2 different languages, Italian and French. And we're going to be speaking in English, the US variety, and then translating it. And it's going to enter into an infinite loop where it's just going to ask me to speak into the mic, translate, display the text, and repeat. And so we'll go ahead and select speech translation and go ahead and run that. I love pizza with extra cheese. So there was no verbal translation, but it took the text that I entered in verbally. It translated that into, it took the speech, translated it to text, took that text, and then translated it into the two different languages, Italian and French. I'm not fluent in either, but judging by the looks of this, it looks like it's spot on. So this would be more useful if you have an international customer base or clients that don't necessarily speak English. This is a good way for them to interact with your application. Okay, any questions?
Maybe I missed it, but that is running up in Azure and not locally on your system, correct?
So the application is running locally. However,
Right, but the model is running on Azure.
exactly, correct.
Okay.
The step that I glossed over was basically looking at my Azure portal. I went into a resource group and then typed in speech services, and then you would just simply select create here. Once this is created, you would take your two keys for the subscription and your region, and you would utilize that in your C# code.
All right, thanks.
Sure. Other questions? All right. So let's get back into our slides. So just as we had seen with speech services, there's also vision services where you can do a variety of different things. You can do object detection. You can analyze the content and images or do OCR on them. There's an article that I wrote, and I'd be happy to share the link with you, where basically I scanned in my business card, and then I was able to isolate all the various aspects of it, name, address, phone number, and then it was able to do OCR on that from an image and be able to extract that text from it. You can also identify people, but again, this comes with an application that you need to submit to Microsoft for being able to do that. And then the video indexer, which is pretty powerful, where you can analyze video and index the content in that video. And then form recognizer, where basically you submit a document and then it can extract various text from it, whether it be a receipt or an invoice, and it would extract that text from it and then allow you to populate a database with it directly. And then the ink recognizer, which essentially is used for handwriting, actual handwriting cursive. And so you can utilize that feature as well. As far as face detection, essentially the reply comes back where we submit, after we submit the image, the reply comes back in the form of JSON, where it's identifying the face that's in the image. And as we see here, it's showing that it's a female, approximate age of 23, and the location of the face in the image and the coordinates where it's located. And then it also gives some additional metadata regarding the image itself, the format, the height, and the width. Same thing with object detection, where we can submit an image and then it can respond back with all the various objects that it sees. So in this case, it sees a computer keyboard, it sees a kitchen appliance, and it sees an actual person sitting in it. And then this is all in the JSON format, and it's giving you the coordinates of where these items are located within that image. Lastly, I want to talk about the AI Foundry. Now that we've gotten to a point where at the highest level, we're utilizing artificial intelligence, this is now utilizing large language models in the Foundry, where it's literally hundreds of billions of nodes that are in use to mimic human understanding and response. So with that, let's get into the Foundry. And we'll go over here. And so this is a demo that I had created previously. And before we get into that, let's do this. Let's close that. And let's go into another project in the Foundry. So these are basically a variety of different models that are available that I can use. And they perform a variety of different tasks. And as we see here, I can filter down on the various tasks that they can perform, whether it's Q&A, text translation, classification, etc., etc. A rather lengthy list. And as you see over in the right-hand corner, over 1,800 different models, and this number is constantly evolving as more models are being added. DeepSeek is the one that is most recent, that was recently added. But then we see a variety of other GPT models, GPT 4.0, 3.5, and a variety of other different flavors. So you can also search by the collection or publisher of that model. So there are ones that are curated by Azure AI, by Microsoft, Meta, Cohere, Databricks, so on and so forth. But essentially, if we want to be able to utilize it, you can go into the playground. And the playground is essentially basically a sandbox for trying out your model. So in this case, I selected or I deployed the GPT 3.5 Turbo because it's a low-cost model and allows me to experiment with it. So when it comes to utilizing a large language model, it has the capability where now I can ask it to act the way I want it to act. I'm giving it a persona and how to respond. So here, these are the model instructions that are being passed in. I am telling the model, you are an AI assistant that helps people find information. So that's the default message. Now I'm going to add to it, and I'm going to say, you are comical and friendly, but you're rude when the same question is asked twice. And as you see, I get a gentle reminder that I need to select the Apply Changes button below. And so I'll go ahead and do that. And if you notice, I didn't structure that in any specific way. I just typed it as a natural language. Now that I'm ready to utilize my model, I will ask it, how many car makers are in the US? I'll submit that, and it comes back very friendly way. The old age question. Well, my friend, there are currently 12 major car manufacturers in the US. Right, so it's a very friendly response. Now, let's go ahead and ask that same question again. And you see, now I'm getting a little bit of a spicy attitude. Didn't I just answer that question? Right? And then it ends it, but seriously, try to remember next time, okay? So this is kind of a fun thing to do, right? But more specifically, what I could be doing is, instead of focusing on the attitude, I can say, keep all answers to exactly 3 sentences. And you notice that now I have a new chat session. So one of the things that to consider in a large language model is the context of what you're referring to. Meaning, I gave it a question, and the next question will build on that previous question. Similarly, if I was talking to one of you and I said, how many car manufacturers are there in the US? And you would list all the car manufacturers. And then I would say, name just the electric manufacturers. So you're not going to look at that question alone by itself, but that question is relating to the first question of car manufacturers. But now that I applied the changes, now it's saying that a new chat session has started, and now it's a different context that I'm working in. So as we see here, previous messages won't be used as context for new queries. I told it to keep all answers to exactly 3 sentences. I'll ask it the same question again. And there we see kept to 3 sentences. And then I'll add on to it, and I'll say start each answer. Yeah, let's do that. Current date. And here's telling me as of the latest date. Okay, now I can go on and modify it, but more specifically, how can I utilize this in business? So I have the ability where I can add in data, and for the sake of time, I'm going to fast forward a little bit. But this is another demo that I had created where I had imported product data regarding a hypothetical company for trail walker boots. So it's an outdoor sports goods company, and I imported a file that is all about the trail walker boots. And so I put that in there. And as you see, the question I asked, how much are the trail walker hiking shoes? And it came back with the answer, it's 110. And here's the reference where it got that from this file. So this is a markdown file. And then when I clicked on it within the playground, it's showing me what that file is. Now, keeping in mind within that context of the hiking boots, I can then ask, what color is it? And then it says it's in black. Is it comfortable? And again, all this is to show that it's working within the context of the initial question about the trail walker boots. And so it pulls up the text relating to that to the file that I'd entered. So where this comes in handy is now I can create my own co-pilot, my own assistant for my own customer data and my own products that I can then share with my customers. So I no longer have to let them rely on Google where they're just shuffling through a variety of different information, but rather they can ask pointed questions and then get pointed answers, all by training my co-pilot on my data. Okay. Any questions? All right. So with that, that pretty much wraps up my presentation. And if there are no questions for me, I would like to ask you, what have you learned here today? What value can you take away from this meeting? I would love to hear your responses, either verbally or in chat. Any takeaways? Would love to hear your feedback.
Sam, I think for me the main takeaway is it's easier than I thought. I think that there has been a reluctance to tackle machine learning AI because it just must be so complicated. And you did a good job of showing that's really not.
Thank you. Appreciate that. All right. Yeah, Kevin, go ahead, please.
Yep. Also, from my perspective, I don't do a lot of data work in my professional job. I mostly work on front ends and, a few back ends. So seeing how to integrate these models in the .NET infrastructure has been fun because I've seen like tutorials online and they'll say go download Olama or this software and that software and you use these tools. But to also put that with the tools I use is kind of fun to see. So
Yeah, so Olama and other language models, you can certainly utilize that, but that involves another layer where you'd have to download another server on your machine to be able to execute those models. The Foundry takes care of that in the sense that that model is now running in the cloud in Azure. And even though it's called the Foundry and it's separate outside the portal, it's actually connected to the portal because everything that I set up in the Foundry ties back to a resource group in the portal, which also ties back to my subscription. So the Foundry gives me the playground capabilities, the ability to search through various models and see the various benchmarks. Not to mention that list of models is constantly evolving. But then in the end, I can actually deploy, and as we see here, all within the playground. I have the ability to set my prompts and give it instructions, select the model that I want to deploy, add my own data, and I can also evaluate it here. And then when everything is said and done, I can select to deploy it as a web application. If I need to access it through an API call in my C# code, I can look at code snippets, and there's my code snippet in Python. If I want C#, that's also available. Same with JavaScript. So essentially, I would just cut and paste the stub code. Of course, I'd have to utilize the keys for my own account, but it's giving me stub code that can get me up and running. Sorry, that was a little bit of a mouthful. As you can tell, I'm very enthusiastic about these things.
Yeah, it's
All right.
exciting. Thanks.
Oh, you're very welcome. Okay, so to wrap it up, we talked about the building blocks, neural networks, how that then is built into deep learning, and then how we build ML models on top of that, and then eventually get to an AI level. We talked about how we can incorporate that in our .NET project, as you had seen in the first demo, how I can utilize AI services through C# code, all by just simply setting up the speech services. And then we took a look at utilizing large language models and the Foundry and how that can be deployed and how we can utilize that and customize that for our own customer base. So some references. For the ML.NET guide, you can find that on Microsoft.com. In addition, there's the ML glossary for all the different terminology. And then for improving ML performance or machine learning performance, there's a nice article on how to improve performance and how to cleanse your data. If you found this presentation interesting, or you think it might be useful, or you would like to have a proof of concept done with your organization, I'd be happy to help you. You can reach out to nistechnologies.com. Also, this is available as a course for your team. And if you need to get in touch with me for any reason or any question, again, just because the presentation ends here doesn't mean the dialogue stops. I'd be more than happy to help you get a proof of concept up and running, demonstrate something to your team. You can find all my links on Linktree/Sam Nasr. But more specifically, you can reach out to me via email, snasr@nistechnologies.com. Again, my links. And then if we're not connected on LinkedIn, let's do so. It's a great way to keep in touch, see latest articles and things, and overall, great platform. Not to mention, I have a few courses published on there regarding AI if you're interested in expanding your knowledge. And so with that, thank you for your time. Thank you for attending. And I hope this was beneficial for you.
All right, thank you, Sam. I'm going to go ahead and redisplay that QR code for the eval as I promised that I would do. So I'm going to go ahead and grab the presenter mode for a moment.
Sure, please do.
Okay. You should be able to see the QR code. And Steve, if you can throw the actual URL into the chat, that would be helpful as well. I don't have
I just
that.
did.
Okay. Very good. Let me go ahead and see if I can grab that. Maybe I can paste that here. Okay. All right. So thank you for attending. We appreciate your attendance very much and your attention. Thank you, Sam, one last time.
Thank you.
Anything follow-up you wish to talk about can be put in the discussion section of meetup.com, GlugNet. And Steve, you said this will be open for 24 hours, correct?
Yes.
Okay, fantastic. Well, be sure to fill out the eval. Sam will appreciate it, and we will as well. Thank you very
Great.
much.
All right. Thank you all. Good night.